If you're not in a building made of bricks here at UVA, chances are you're walking on them. Well, did you know the same clay used to make bricks is also used in pottery?
Pottery is generally divided into three categories: earthenware, stoneware, and porcelain. Bricks are considered an example of earthenware pottery.
Clay is a very versatile material, composed of tiny mineral particles like kaolinite, illite, and montmorillonite. These materials are hydrous aluminum silicates with unique properties that make clay ideal for pottery and bricks. Here you can see some diagrams of these clay mineral structures, noticing how the silicate tetrahedrons form sheets that fit together nicely in different ways with the aluminum octahedron sheets. Kaolinite, for instance, has a simple 1-to-1 layer structure and stronger bonds, which gives it low plasticity and increased stability at high temperatures. Montmorillonite, on the other hand, has a 2-to-1 layer structure and weaker bonds that make it very plastic and able to absorb a lot of water.
Construction with clay initially started by just piling wet clay to form walls and structures. However, the invention of the sun-dried brick allowed for larger and more complex structures to be made, such as the serpentine wall behind me. Furthermore, the invention of the fired brick, which used kilns instead of the sun, allowed for bricks to be made in cooler climates, further expanding their range of use.
When fired in the kiln, clay changes. Free water evaporates, and then at higher temperatures, chemically bound water is released through dehydroxylation. As temperatures increase further, clay particles begin to sinter and vitrify, which is a sort of maturing process where they fuse together and some minerals melt and form a glassy matrix. You can picture this change by imagining breaking a piece and seeing a clean break where you could fit the pieces together perfectly. These changes harden the clay, make it less porous, and give it the durability that's essential for pottery and bricks. If heated too much, the process can be overdone, which can cause bloat and deformation from expanding glass bubbles. In pottery, natural clays like ball clay are often mixed with kaolinite in order to provide a good balance between plasticity and stability when fired in the kiln. For brickmaking, purer fire clays rich in kaolinite and illite are preferred because they withstand high temperatures and environmental stresses that make them perfect for structural applications.
Hey guys, welcome to my Play-Doh haul. So as you can see here, I got some Play-Doh. So, Play-Doh is just like clay. I know, crazy. And just like clay, Play-Doh is made out of tiny, small grains that can come together. These are held together with electrostatic forces and water surface tension, along with friction between the particles. The strength of clay, just like this Play-Doh, can be measured as a function of shear strength, which is resistance to tangential deformation. The undrained shear strength of clay is vital. Because the voids are small and poorly interconnected in clay, water drains slowly, which is represented with a very small coefficient of hydraulic conductivity, a table you can see here, and that is a measure of how fast water flows through a soil. As an incompressible fluid though, water in the pores is able to take on loads, which increases clay's strength. This is why we all hate dried out Play-Doh. It's so weak without the water to help bind it and take some of the load off. Shear strength can also be used to calculate bearing capacity and soil stability, or Play-Doh stability in this case.
All of these unique properties of clay, from its plasticity to its water absorption, have a significant impact in geotechnical engineering, where clay's behavior in soil is critical. Its widespread presence in soils directly affects how projects are planned and executed in clay environments. Some common applications involving clay in geotechnical projects include landfill liners, embankment dams, highway embankments, and foundational materials such as bricks. For each of these, the soil's clay content must be carefully analyzed as it directly influences how water will interact with the soil.